Welcome to the statistical learning session. Today, we'll continue with the column group spin-off test. Column group spin-off test is a non-parametric method to determine whether an empirical distribution deviates significantly from a hypothesized distribution. By leveraging Donsko's theorem, this test provides an asymptotic framework for hypothesis testing, particularly useful when limiting behavioral test statistics follows a properties of a Brownian bridge. Now let's dive into our definition, our presentation. Now let's start with the test statistics. TN here. TN here is a test statistics and it's equal to soup of square root of n and absolute value of difference between fn of t and fn not of t, and t belongs to a real number line. Here fn t is an empirical distribution function, while f naught t is a hypothesized distribution function under null hypothesis H naught, which we did in last session. As a next step, we will rescale by square root of n. Now we are rescaling by square root of n. The test is rescaled by square root of n, which is appropriate normalized based on Donsko's theorem. This is appropriate normalization based on Donsko's theorem. And as it is prepared for Donsko's theorem, we have normalized by square root of n. Now, let's utilize Donsko's theorem. Apply Donsko's theorem to understand the asymptotic behavior of Tn under S naught, that is, Tn tends to go to Tn with the test statistics, it will go to the z value definitely when n goes to infinity, where z represents a supremum of absolute value of Brownian bridge. Now, to perform tests at a significance level alpha, do you know what we need to do? Think about it. We need to determine the critical value of Q. We need to determine the critical value of Q alpha of Z. And this is done by from tables or simulations. And then, what's the next step of this? What formula would we use to reject the null hypothesis? Can you tell me anything about it? We would reject the null hypothesis H naught if this is true. That is, if this produces one value 1, then if this is true, then H naught will be equal to 1, and if it's 1, then H naught will be false. Now, let's compute p-value. The p-value is calculated as a p-value is calculated as a, let me go and remove this. P-value is calculated as a p greater than z given Tn. P greater than Tn. P greater than Tn given Tn. This is a probability that a supremum of absolute value of Brownian breeze exceeds the observed value of Tn. It's a probability that a supremum of absolute value of Brownian breeze. This is a supremum of absolute value of Brownian breeze exceeds. This is G. This is G is the supremum absolute value of Brownian breeze exceeds the value of Tn. Given value of Tn. Now, Colebrook's test summary. The case test assesses whether F and T differs significantly from F and F naught T. If Tn is lower than Q naught, will fail to reject H naught. Otherwise, H naught is rejected. Now let's interpret the results. Recognize the assumptive behavior of Tn is derived using Downstairs theorem. The uniform central limit theorem. The test has an assumptive level alpha due to the use of this theorem. Now let me summarize what we learned today. Kolmogorov-Smirnov test provides a robust method for testing the conformity of an empirical distribution Fn to a hypothesized distribution F naught. By utilizing Downstairs theorem, it determines whether deviation of Fn from F naught are significant based on critical values of supremum of the Brownian bridge. This test is widely applicable across different contexts due to its non-parametric nature and assumptive properties. That's all for today. I will see you next learning session. Thank you so much. Have a nice day.